Hello and welcome to section 9.2. In this video we'll be going over the composite body method to solve for the center of gravity, center of mass, or centroid of shapes that aren't continuous. They're commonly made up of common geometric shapes such as rectangles, triangles, and circles. So what we're going to be doing, if you remember, if I wanted to find, say, distance from a bunch of moments, I could do sum of the forces times the distance for each shape over the total sum of the forces. So what we're going to be doing is a very similar procedure, but instead of distances, we're going to be doing areas and volumes and weights, depending on what we're trying to find. So we're going to break that up into this table down here, just to kind of help us with bookkeeping and make sure we find all of the stuff. Now, you don't need to use this table. I just prefer to use this table or similar types because it helps us to organize things. Example 1 has us do this wire that's been bent in 3 directions along the x-axis, in the y direction, and then down in the z direction. And the table has been pre-set up, so let's solve that. So you can see what we have here, and then for each of these shapes, so we have our wire along the x, and then we have it bent in the y and then down in z, so it's fairly simple. I've tried to indicate the centroids of each of these, roughly where the circles are, and I've also labeled these segments. So that's one of the first things you have to be able to do, is break your thing apart into segments. So let's motivate why we'd want to find all this information. So say we wanted to find x bar. In this problem, x bar would be the summation of all of the length of the bar, which we would find by adding up all the numbers in this column. And then we would weight each of those individual segments, so segment 1, segment 2, segment 3, we would find each individual centroid in the x direction. And we would add all those up. And that would give us x bar. Y bar and z bar look similar. Oops, they should be a y. There we go. So the cool thing is once you find sum of L, it doesn't change for any of these, so you don't need to resolve for it. You just solve for the numerator. Alright, so let's look at segment 1. So segment 1 is this piece, the first piece that runs along here. We want to know where is it, so I suppose I should probably use tildes here instead of just bars, because we're only finding it for that specific segment. So for segment 1, the midpoint of this, the centroid of this wire is right here where I've marked the blue spot. So this thing is 300 millimeters long, which means its midpoint is at 150. So I will record it as millimeters. Everything's in millimeters, which means that when I do my math, I'll get millimeters over millimeters, and it will all work out. In the y direction, the entire bar lies at 0 in the y direction. Same thing in z. So I don't have, so if I was kind of like trying to find the location of this point is at 150, 0, 0, if you want to write the coordinates of it, which is what we're doing. And then the last piece of information I need is how long is this bar? This bar is 300 millimeters long. All right, shape 2. Let's start with the easy thing. How long is it? It's 600. So if you wanted to, you could put this first. And then you say, okay, what's the coordinate of this blue dot, the center of this segment? Well, it is at 300. In the x, half of this in the y, which is 300. And in the z, it's 0. And then for segment 3 is 400 millimeters long. And then we want to find the coordinates of the centroid of this, so the blue point. So that's also going to be 300 in the x, 600 in the y, and then we'll have a negative z component. So 300, 600, and then this is actually negative z, so it's negative 200. So at this point, you've filled out all of their data, and then you can just solve these equations. So as a bonus, let's apply this to one of these. So let's find z bar. It's the easiest to find. So z bar is equal to the sum of the z times L over the sum of L. So for the sum of L, we just add up all of these numbers. We'll get a total. Our total will be 1,300. Sorry, not 1,300. 13, and then we have 1, 2, 3, 4, 5, 6. E6. So 13E6. So there's 6 zeros on that. And then in the Z direction, I get 0 for segment 1 because there's a 0. I get a 0 for segment 2. So we'll get 0 plus 0 plus, and then for the segment 3, I'm going to get negative 200 times 400. So I will get a negative 8, and then I'll have 4 zeros. So e to the 4. And then you just do that algebra, and it'll tell you where z bar is. Actually, that's a mistake. This is plus, not multiplication, so you only get 2 zeros here. So 13e2. Then you can do your math. And you'll find that it is a negative 61.54 millimeters. So negative makes sense. If you kind of come back up here and you look at the thing. So we wouldn't expect it to be at the, we'd expect it to be above the centroid of this because I have a whole bunch of wire that's up here at basically z equals 0. So above this but below this makes some sense. So it seems like we're in the right region at least. All right. Hopefully that helps. If you have any questions, feel free to reach out.